Hey again, Hawks. So, yesterday we learned about ionic bonds and how ions can come close to each other and then they end up having that force of attraction, which is really hard to break apart. Today we're going to talk about the ionic compounds that are formed because of those ionic bonds. Okay, so we're going to talk about ionic compounds. Again, on our trek to figure out how our gemstones form. And I will explain how ions bond together to form ionic compounds. Okay, so ionic compounds, remember those are formed when you have the ions that come close to each other, right? And then there's this force of attraction between the ions. Well, it comes to find out that it's not just a force of attraction between the two, it's really a force of attraction between all of them. Okay. So, for example, this compound here where we have sodium and chlorine, and so we have a sodium ion and a chlorine ion, and those two are fairly close to each other, and so they have that really hard force of attraction. And I have another set here where I have a sodium ion and I have a chlorine ion, and those two have a really good force of attraction. But because this is still a positive ion, it's not totally like by itself, this sodium also feels a little bit of attraction to this chlorine. And so you can see the line here is longer, so it's not as strong of a force as the force that's interacting between these two. But then as you go, they kind of flip-flop and they form what's called a salt. Okay? And so ionic compounds are really known as salts. And those salts have properties that are, in this case, they tend to be three-dimensional, very cubic-like, very lattice structures. So you can see that there's kind of a lattice being formed here, crystalline type structure. They are solid at room temperature. So, at 70 degrees Fahrenheit or 40 degrees Celsius, they tend to be solid. So when you're thinking it's a salt, yes, NaCl is table salt. So if you're imagining what table salt might look like, that's what this is. Okay. They have a high melting point, which means that, under a regular fire, they won't melt, right? Because a regular fire is somewhere between, 90 and 120 degrees. And so that fire is just not hot enough to melt the crystals. Okay. And it has a very high boiling point, which means, if I did finally get it to melt and become a liquid, it would take even more energy for it to actually boil and become steam. So, and when we're talking high, I'm talking really high. Okay. Water boil or water melts at like 32 degrees, which is 0 degrees Celsius. Water is not an ionic compound. Okay, so that's a low melting point. A high melting point might be somewhere in the 100s, and then its boiling point might be somewhere in the 300 or 400s. Okay, they also conduct electricity and heat very well. And what that means is if they're in contact with electricity, the electricity will flow through the ions, right? It'll flow through the lattice and come out the other side. And then with heat, if I apply heat to one corner, it will spread quickly throughout the lattice. Okay, so ionic compounds tend to form a lattice structure. They are solid at room temperature. They have high melting points and high boiling points, and they conduct electricity as well as they conduct heat very well. So let's look at these two things, okay? We have table salt and sugar, okay? Which compound forms an ionic bond? Okay, so let's look at this. Regular table salt, sodium chloride, okay? It's solid. It looks like small cubes. Like if you look at it under a magnifying glass or a microscope, you might see like it looks like it has little tiny cubes. Okay, it's white. Um, you know, doesn't crush very well. Melting point. Its melting point is 801 degrees Celsius. Okay, so that's pretty high. Its boiling point is 1,465 degrees Celsius. And if I attach electricity to it, it would turn on a light, right? So if I had a light bulb and I put the electrodes so that there was sodium in or table salt in between, it would still turn on a light. Okay, it would not make the light go out. Sugar is white. It's solid. It looks crystalline. So, if you look at it under a microscope, it does kind of look like there's small cubes or cube sort of looking objects. Its melting point is 186 degrees Celsius. Okay, so about 86 degrees higher than water. Its boiling point is about 186 degrees Celsius. So basically it's going to melt and then it's going to turn right into, well, it's going to burn. Okay. And then if I tried to put electricity through it, it wouldn't travel. The electricity wouldn't travel. It wouldn't make the light turn on. So which of these two do you think is the ionic bond? Now remember, ionic bonds are solids at room temperature. They have high melting and boiling points, and they conduct electricity and heat very well. So if we look at these two compounds, you'll see that the table salt is the one that has the really high melting point, the really high boiling point, and it's conductive. Okay, so now you should be able to tell the difference between an ionic compound and a non-ionic compound.